Hello everyone, thanks for joining me. This is Steve and I'm going to graph the parabola associated with this quadratic right here. So the first thing I notice is we got this negative sign hanging out in front, which is actually a -1. But either way, since we have a negative number hanging out in front, this parabola is going to be opening down like this. The other thing I could write down right off the bat is that the domain is going to be -infinity to infinity, because the domain is -infinity to infinity for all quadratics and their associated parabolas. All right. So let's find the vertex of this sucker, the most important point. Now, the vertex can be found just by looking at the equation itself, by looking at these two numbers. But please remember that when you're giving the vertex, you need to give the opposite value for the x value that you see in the equation. So it's not going to be a -1 for x, it's going to be a +1, but the y value is fine the way it is, so it's going to be 1, 4, like that. Once we have our vertex and we know the direction that our parabola opens, we can give the range right off the bat. So this one's going to go down forever to -infinity, and its highest value is going to be the y value of the vertex, which is going to be 4. Okay. Oh, also once we get the vertex, we can give the axis of symmetry. Don't let the axis of symmetry spook you. It's always a vertical line, so it's going to be x equals, and it's just going to be the same x value as we found in the vertex. So x equals 1, just like that. Okay, y-intercept. Y-intercept is a little bit tricky. It's not just going to be the number at the end of the equation. The way you find the y-intercept is you have to plug a 0 into the equation. So, if we plug a 0 in there, let's be very careful. Look at all these negative signs. Let's see what we get. So 0 minus 1 is -1. -1 squared is +1, but there's still a negative hanging out in front, so we actually end up with -1 plus 4. Or +3. So our y-intercept is going to be 0, 3. How do we find that? Not just by looking at the number at the end, but by plugging a 0 in for every x and crunching out a y value, 0, 3. Okay, let's see where this particular graph is going to have its x-intercepts by finding the zeros of the original function. So I'll take the entire equation, set it equal to 0. And once again, I have to be careful with this negative sign here, because what happens is usually when I try to find the x-intercepts is I'm going to subtract that 4 from both sides. But before I take the square root of both sides, by applying the square root property, I need to kill both those negative signs. More importantly, this negative sign can't be here. So I'm going to multiply both sides by -1, and when I do that, it gives me this. Now when I apply the square root property, I'm not taking the square root of -4, I'm taking the square root of 4, as I should be. So plus or minus square root of 4, this cleans up really nicely. X minus 1 equals plus or minus 2. If we go ahead and add the 1 to both sides, we will get that our zeros are going to be -1 and 3, and therefore our x-intercepts, the ordered pairs, are -1, 0, and 3, 0. Okay, so we have our vertex, our y-intercept, our x-intercepts. We know which way it opens, we know the range, we know all sorts of stuff, so now we are ready to draw a graph. So let's do that now. Okay, here we are everyone, about to draw our graph. And let's put our vertex in first. That's going to be at 1, 4, right here. And we also have a y-intercept at 0, 3. You know what? That y-intercept at 0, 3, I bet it's got a friend on the other side of the parabola because all of our parabolas are symmetric. So if I put in my axis of symmetry, I can see that I'm going to have another point right here, a reflection of the y-intercept. I also have some x-intercepts that will help me draw this. I've got one at -1, 0, right here, and another one at 3, 0, right there. And those are both equal distance from the axis of symmetry. Okay, this should be enough to draw a pretty cool graph here. Nice smooth cup up there. Come down like that. Come down like that. All right, everyone. There's our parabola. And here's the information we used to graph it. I hope that helped. Thanks for watching.